This is Constricting the Web, offensive Python for web hackers. So if you didn't know that, you're in the wrong talk. I am Nathan Hamiel. I'm a principal consultant for Fishnet Security on the application security team, and I'm also an associate professor at the University of Advancing Technology.
And I'm Marcin Wielgoszewski. I'm not going to ask you guys to repeat that, but I'm a security engineer, Gotham Digital Science. I do web shit, so.
Kind of the reason we decided to do this talk is because there's a lot of people who are starting to get more into testing web applications, and web applications are becoming more complicated. So first things people usually reach for are their toolkits. So maybe it's AppScan or Web Inspect, but they don't really give you the whole picture. A lot of times vendors are playing catch up. So with new technologies like Flash and Silverlight, it might not be supported for quite a bit of time between the time people are using it and the time the technology catches up with to be able to test it. So it's not like you can just say, we have this new technology, we'll just wait till everybody catches up and then we'll check to see whether it's secure. That's not really setting you up for success there. There's also difficult cases where your standard testing tools won't really help you. APIs for one. So if you're going through testing your application, you run into an API, you might not even see it. The scanner might not even see it unless it makes some sort of call. There's also sequenced operations as well. So if there's a sequence of steps that need to happen prior to a test case, sometimes standard tools will fall flat on their face. With randomized data, if a page lays out, and every single time the page lays out, the data is behind the menu options is randomized, there's pretty much no testing tool out there, standard testing tool that will help you. And that's why you need to write your own tools. So this is an intervention. I see a bunch of people who love you like crazy, and they want you to join the fight and not just use AppScan and Web Inspect. Now, this wasn't in our previous slide, so what we have already posted is the slides for this talk as well as the code snippets that we're using. So we're releasing a few tools, and we're releasing some example code that's already available for download. So if you get a chance and you want to play around with that, that's all well and good. Here's kind of an example snapshot of some modern infrastructure. If you look at this infrastructure and how it's laid out, just the front end web page, which web vulnerability scanners are really good at testing, isn't really the bigger picture. It's only a small percentage of your entire attack surface. So that being the case, if you just ran these standard tools and generated reports, you wouldn't even see any of these other things. These client APIs, server-to-server APIs, storage mechanisms on the back, and that's kind of just leading more up to the point that you're going to have to write your own tools if you want to be successful.
So why do we use Python? I think we all know because it rocks, right? You could quickly write tools, on a whim. That's one of the things, like when you're testing stuff, like the lifespan or whatever of your tool actually just lasts as long as the app stands up, After that, it's just a throwaway. Easy to understand, and I kind of like the white space. I guess most of you do too. That's why you still use it. Otherwise, you'd be back to Perl. So
there's plenty of support out there for Python as well. One thing I will advise against not doing: do not go into the Python room on Freenode and start lulling. They do not like that. I am perma-banned from the Python IRC channel on Freenode, but I thought it was funny. So you can Google for plenty of examples. There's also a search engine called Knowledge. That's a Python source code search engine, which comes in helpful, especially for poorly documented modules. You might find that useful. I think I saw that from a tweet from Dave Eitel. He's like, "Hey, Knowledge," and I'm like, "Cool."
I guess poorly documented Python code, you don't even want to use any, if you can't read the source, might as well just skip it.
So there's plenty of help available.
So a few of the big tools out there, I mean, like anyone coming from like network side knows Scapy. I love Scapy. Peach, fuzzing shit, like that's awesome. From like the reverse engineering side of the house, like you got IDA Python, you got PyDBG. My buddy Rich Smith just released a toolkit yesterday called Pyretic, basically deobfuscating or reversing out obfuscated Python bytecode, which is pretty badass. W3AF, web scanner, you guys probably all familiar with, written in Python as well. So a lot of stuff out there already, and it's kind of like a lot of people's insecurity like to use Python, so those are the big ones.
So it kind of gives you an opportunity too to not only use tools that are already written in Python, but also for extending them as well and contributing back to those projects. So where does Python fit? Python fits in the space between your fully automated testing tools and completely manual testing. So you can have just as much context over what you're testing as manual testing, because you're basically writing the clients. You're basically using the tools. You know exactly what data is going to the application and what's coming back. So that's the place it fits. Automating your manual testing cases. There's a couple of different versions of Python. We only highlighted 3 here that may be of interest to you. CPython is the standard Python implementation that you probably have running on your system. Jython is Python in Java, and IronPython is Python in .NET. So we'll go into that a little bit later. Other than just having an excuse to put Ron Jeremy in a slide.
Piss off Ping.
Yeah. You have to know, you have to be intimately familiar with your applications before you start testing them. And I realize that sounds kind of strange, but a lot of commercial testing tools are meant to abstract you from being familiar with the application. You can get down and dirty with them, but that's not typically how they're used in the infrastructure. So that's kind of what this slide was about.
You guys are probably all familiar with the standard library. You keep the docs under your pillow, like, whatever. Some of the third-party modules that you might not be aware of, like HTTP lib2, URL lib3, LXML, a couple of the others, just make testing so much easier when you're writing your own tools. But yeah, we'll go.
How many people in here have used LXML?
It's awesome, okay, right?
So cool. We're going to talk about that in a little bit too. We didn't really know how familiar everybody was going to be with Python. So inside if you wanted to see some examples of like cookie handling and a couple of other things, you can see those inside the code snippets thing that we released. So a little tool I wrote when I was writing Monkey Fist that I released last year is basically a reflector for requests. So when you're structuring your requests together, and you're adding headers and you're making modifications, you might want to know what the web server is going to see. And I wrote this little thing, and it's in the code snippets thing as well. It's called reflect request. You hit it, you run it, and anything you send to it, it's going to send back to you. So any get, post, put, or delete. So when you're building your clients, you can verify without having to set up a separate web server. It just implements the base HTTP request handler class and handles those requests.
Basically, just trace implemented in a couple lines. So, whatever.
Data representations. So we've kind of moved on from like building a client. You might want to represent that data in a different format. So whether it be URL encoding, hex encoding, Python has everything in Python's an object. So any string object has encoding methods. So you could do things like base64, hex, even rot13. And I realize that rot13 sounds kind of ridiculous to all of us as security people, but as recent as like 2 months ago, we were looking at an application that was trying to obfuscate paths with rot13. It's actually ridiculous because you actually get to see like where it's like mapping drives out and stuff. So just because I like having a standalone encoder when I'm doing assessments, I wrote this tool called Dharma Encoder, and the magic of Dharma encoders in the encoder lib, as you would imagine. So it's open source, you can download it, and you can see all the different data representations there. So on the next page is a screenshot, and all you have to do is choose which method you want to encode to, and then you can also wrap it in like script tags, and there's probably bugs in it, so let me know so I can fix them, or if there's features that can be added or that you would like,
Mm-hmm.
let me know, and I'll get those added.
So when you're like breaking web apps, like the three most common formats that you're going to get back in a response is like XML, HTML, or JSON. One of the things like, what was I going to say?
You're going to talk about like Beautiful Soup.
Oh yeah. So how many people here actually heard of Beautiful Soup or used Beautiful Soup? Okay. LXML, less than that. But basically, if you're parsing like HTML content or XML content, you want to actually use LXML over Beautiful Soup. The author of Beautiful Soup just expressed interest or lack of interest in supporting Beautiful Soup. LXML is a lot better. It's a lot more fault tolerant, and also is a lot better at handling malformed HTML content. So your parser doesn't break as soon as like it's got some mismatched tags or something.
So is there anybody in here that thinks that the web isn't broken? Like everything is all well and good in tags? Yeah. Our browsers have become really good at handling malformed HTML.
So
also, don't use the built-in HTML parser either in Python in the standard library, because it's not fault tolerant either. So you need to be able to, you need to send it cleaned HTML that's able to be parsed first.
And the other nice thing about LXML, it's actually written in C, which actually kind of makes it a pain in the ass for like cross-platform compatibility. But if you get it working, it's awesome. Basically, it's a lot faster than the Python implementations of XML parsing. And it's fast. It's great. So just an example, just parsing HTML content with LXML. You know, say we want to get out all the links from a HTML response. We just iterate over every A tag and then get the href attribute from it. Simple as that. One of the nice things, or one of the things I find useful parsing XML content is like XML configurations. So you got like a web.xml, and you have a bunch of servlet classes and servlet names. When I do code reviews, I parse out these web XMLs and get like just a list of all the servlet classes and the URL patterns, and just kind of map, see what I've reviewed so far, and what I've got to review in the future, black box and stuff like that. So this is just an example showing using XPath expressions to actually get various XML nodes. So very simple.
JSON is obviously very, very popular now. So JSON maps pretty much directly to Python types. So, I mean, a JSON object is a Python dictionary, and a JSON array is a Python list. So it makes it really nice. JSON, as of Python 2.6, is built into the standard library. This is just in a couple lines of code. We'll go out to Twitter and grab all the current trends and print them out for you. Pretty simple. So when you're building your test cases, you're building fuzz cases for testing your web apps, you're going to want to be familiar with your application, its parameters, and its data. There's certain thgoing that you're going to want to make sure you test, and then certain things that might not be so important. So look, if you're fuzzing like an API, you're going to want to make sure that you're sending things in the correct data format. If you're not encoding the data properly, you might have invalid cases to where you never find specific vulnerabilities.
And the other thing, like when you're generating fuzz cases, like work smart. There's various like itertool methods that make generating this stuff like really simple. And when you're actually throwing stuff at the app, don't throw everything you got at once. You're never going to test, never going to be able to like explore all the code paths if like every parameter is just junk. So yeah, if you have like a string of post data that you're testing, you're going to want to iterate through it one by one by one, and not throw every single thing at every single variable every single time. So an example of this is using the product method from the itertools module. Basically, this creates a Cartesian product of two iterables or two lists against each other, so that like our output is like just fuzzing one parameter at a time per each like attack string, so that we could efficiently do our tests. So I'm like losing like the English language. It's not just Python, so bear with me, guys. So I created this this Python module called PyWebFuzz.
And what it does, has anybody ever heard of FuzzDB? Collection of values for testing? Well, today's your lucky day. So now
it's like a huge dictionary of just like various fuzz